Okay, so writing a function rule from given information. Don't worry, we're waiting. That's okay, it could be worse. We could be 15 minutes into the class and they ask, do you have a pencil? There's nothing more, well, I should say there are a few things more annoying than that. But there are some things that are more annoying than that. So, here we go. Today what you're going to be doing is you're going to be writing equations. You will also use those equations that you were writing, bless you, to answer some of the questions. Okay? Now, the first one, writing a function rule. Read all the way through it first before you start doing your work. Okay? You can estimate the temperature by counting the number of chirps of the snowy tree cricket. The outdoor temperature is about 40 degrees Fahrenheit more than 1/4 the number of chirps in 1 minute. Write a function rule that models the situation. So, a couple of things. We need to pick variables. Do not use X and Y unless the question you are asked specifically says use X and Y. Use variables that make sense to the problem, so when you analyze the problem, the question, so if you solve something, it works out, you know what you're talking about. You don't have just X and Y. So for example, I read the first one, the two things that I'm talking about temperature and I'm talking about chirps. So my variables would be T for temperature and C for chirps. Pick variables that make sense for what you're talking about. Okay? First thing you want to do. Now, the second sentence gives you all the information that you need to be able to write your equation. Okay? The outdoor temperature is one of the most important words in here. Is means equals. Temperature equals. Temperature is, that means T equals. You need to decode the sentences. That's what we're doing. We're decoding the English language to come up with it in terms of math. To look for key words. Is one of those key words. Is means equals. When you see is, that's going to be where the equals goes in your equation. Okay. Then we start looking at the rest of it. 40 degrees more. When I see a more than, what's that generally mean that I'm going to do? I'm going to add. So that means for this one here, I'm going to have a plus 40 somewhere. I'm going to take whatever I get and add 40 to that. That's what that 40 degrees more than means. Ooh, that means I'm going to add 40 somewhere. And then I look at the next one. 1/4 of the number of chirps. I want to find 1/4 of something. When you see of, think times. Of 90% of the time means times. So 1/4 of something means 1/4 times that. So this part here means that I have 1/4 C. 1/4 the number of chirps. C is the number of chirps. I want 1/4 of that. 1/4 times C. And then I have to add my 40 to that. Okay. So if you look at the equation, the temperature is 40 more than 1/4 the number of chirps. This makes sense with the information that was given to us. That's what you're looking to do. Take the information, decode it to be able to write it in terms of math. Okay, this is probably one of the most difficult things to do. Students struggle with changing it from words to math symbols. But being able to do that means that you can solve problems, means that you can make applications. Now you're. Okay, so let's take a look at the second one. Same concept, same ideas. First thing you do is read all the way through it. We had problems this morning with kids getting stuck on one of the problems because they didn't read all the way through the problem. They read halfway in and stopped. And they were getting it wrong because of that. They got stuck. Okay, so a landfill has 50,000 tons of waste in it. Each month it accumulates an average of 420 more tons of waste. What is the functional rule that represents the total amount of waste after M months? I like this. You look at this problem right here. It gives me one of my variables. It tells me to use M for months. It tells me right there in the problem, M is months. So I have to figure out what the other part is. What's the other thing I'm talking about is waste. So that means I'm going to use W for waste. Okay. So that makes sense. W for waste, M for months. And they give me one of the variables in there. Man, it's nice when they give you the variables to start with. And now you just have to figure out the relationship. So how much waste do I have in the landfill to begin with? 50,000. I have 50,000 no matter what. Okay. And then I'm adding to it. I'm adding an average of 42,000 more tons of waste each month. Each month I'm adding that much more. So the amount of waste I have is the 50,000 I start with. Okay, because that's what I have there to begin with. And then I'm adding to that. Okay, it accumulates. Accumulates means that I'm adding. I'm adding how much? I'm adding 420 per month. Okay. Each month I'm adding 420 more. So at the end of 1 month, I'm going to take 1 times 420, add that to 50,000. At the end of 2 months, 2 times 420, add that to 50,000, and so on. Okay. Does that make sense? Do you understand where the equation came from? Because that's what you need to understand to be able to do this. Now, I had a question earlier today. Could I have written it as 420 M plus 50,000? Yeah, I could do that. Because when I have addition, it doesn't matter which one comes first. So if you're more comfortable with that, that's okay. If you're subtracting something, though, you need to be careful. Subtraction order matters. You can't just switch things with subtraction. You can with addition, you can't with subtraction. Any questions so far? Okay. There we go. Okay. Concert revenue. So this next one, we're going to write a function, and then we're going to use that function to figure out to answer another question. So concert revenue. Concert seating plan is shown below. Reserved seating is sold out. Total revenue from ticket sales will depend upon the number of general seating tickets sold. Write a function rule to represent this situation. And then, what is the maximum amount of money I can bring in? Okay? So, a couple of things I need to figure out. First one, how many seats do I have in the reserved seating? 120. How'd you get it? Yeah, 10 times 12. 10 rows, 12 seats per row, 120 seats. How much in the general seating? How many seats do I have here? Although we don't need to know that right away, we will need to know that later. How many seats are there? Yeah. 30 rows times 16 per row, 480 seats. We don't need to know that right away, but we will need to know that later. Okay. Now, the amount of money we are going to bring in, I'm using money, although R would be okay, is equal to the amount of money we bring in from the reserve seating plus the amount of money we bring in from the general seating. Does that make sense? The total amount of money we get is what we get from the reserve seats and how much we get from the general seats, because they're different prices. How much do the reserve seats cost? $25. So the amount of money we're bringing in is 25 times how many reserved seats have we sold already? 120, because we sold all of them. So we've done all the money making we can off of that. Reserved seating sold out. That's good. The expensive tickets are sold. That's nice. You want to sell the expensive tickets first. Okay. Plus, how much does it cost to sit in general seating? What are the cheap seats? $10. How many of those have we sold? No, that's how many we can sell. How many have we sold? We don't know. Right? What do we do when we don't know? We put a variable in there. G for the general seats. Does that make sense? Okay. So what's 120? What's 25 times 120? How much money we already made? $3,000. So the amount of money we're going to make is the $3,000 we've already made plus $10 for every general seat we sell. This is not our final answer. However, this is part one. Okay. Really? Thank you. So that's part one of what we did. That's the equation to describe how much money we're going to make. Now, the second part is, what is the maximum? What is the maximum possible revenue? Well, the maximum possible revenue means that we sell out, which means we sell how many general seating ticket seats? How many of these tickets do we need to sell out? 480. So what do? We put 480 in for G. So we have the amount of money we're going to make is 3,000 plus 10 times 480. So the amount of money we're going to make is 3,000 plus 4,800, because you just tack a zero on the end. Add them all together, what's the amount of money we can make? $7,800. Not bad. Depends on how much the band is going to cost. If I'm the band, then I'll make a lot of money. Not a lot of seats. How many seats are there altogether? What, 600 seats? It's not a very big venue. Nope. But that's all right. Okay. Now, you're going to have several problems just like this on your classwork. Please pay close attention. Okay. So, write a function rule for the area of a rectangle whose length is 5 more than its width. What is the area of the rectangle when the width is 9? So I have 2 questions. Question number 1, write a function rule. Question number 1. On here you have the rectangle drawn. On your classwork, you will not have a rectangle drawn. On your classwork, draw a rectangle. It will help. Label the rectangle. 2 parts of a rectangle. I have the length, and I have my width. Two parts of the rectangle, length and width. Everything revolves around the length and the width of the rectangle. What's the information it gives me about the length? The width. 5 more than means I'm going to do what? Add 5. So I add 5 to the width. So my length is actually the width plus 5. J. Stop. So that's my length. My length is 5 more than the width. This is what my length is. I'm not going to use L anymore. I'm going to use this. How do you find the area of a rectangle? What's the formula for the area of a rectangle? How do you find it? What? Length times width. So I multiply the length and the width. So that means I multiply the width times the length. There's my formula. Okay, so there's my function rule. There's the first thing I'm looking for. Area is W times W plus 5. The width plus length. What?
Is that an and difference?
No, it's a W. It's just a crappy written W. Okay. Now, that's just part 1 of my question. Part 2 says what? What is the area when the width is 9? When W equals 9. What does that mean that I do? That means that I put 9 here and I put 9 in there. My area equals 9 times 9 plus 5. What's 9 plus 5? 14. What's 14 times 9? How much? 126? Easy peasy. This is what your classwork is going to be today. Questions on this?
No.
Okay. So